Welcome everyone, and thank you for joining us. My name is Jessica, and I will be your host for today's webinar, Leaving MPLS for IP and Broadband, Exploring the Cost Savings of SD-WAN Alternatives for Europe. Today I'm joined by Greg Bryan, Senior Pricing Analyst at Telegeography, and Carl Brown, Product Marketing for the Delivery Networks Group at Citrix. In today's webinar, our experts will explore how global DIA and broadband networks come at a significant discount to traditional MPLS VPN without sacrificing security, reliability, or functionality. Before I turn this over to our speakers, let me review a few housekeeping details. We will have a live Q&A session toward the end of today's event, and you're welcome to submit your questions during the presentation using the Ask a Question window on your screen. Simply type your question into the Ask a Question window and click Submit. Also, we're recording this event, and the on-demand version will be available from the same link you used to join today. So feel free to come back and watch the archive and share it with your colleagues. Finally, the slides are available for download from your Event Resources tab. I'll now hand it over to Carl to begin the presentation.
Thanks, Jessica. In today's webinar, Greg and I intend to cover how the enterprise WAN is evolving. And from there, we'll transition over to Greg, who will present a business case for how using a software-defined wide area network approach by combining lower cost services such as dedicated internet access and broadband with MPLS can reduce overall wide area network expenses. And from there, I'll give you a brief overview of the software-defined WAN solution facilitated by the Citrix Cloud Bridge platform. And of course, we will have time at the end to answer any questions that you might have. With that, let's begin the presentation. At Citrix, we see many enterprises evolving their enterprise WAN from the traditional approach which you see on the screen now in front of you, where a data center, which hosted many applications including XenApp or Zen Desktop from Citrix, connects out to branch office locations using a typical MPLS service. That's been the traditional model for many enterprises and still often cases used. But along come a number of apps such as Microsoft Link, which begins to introduce more traffic over the MPLS network instead of as it replaces telephony within the enterprise or video conferencing within the enterprise. And of course, YouTube. YouTube is no longer just a site for entertainment content, but many enterprises, including Citrix, use it to host legitimate corporate content that we make available to our customers and our partners and our employees for viewing purposes. Video is very, very bandwidth intensive, and so as end users within the enterprise go out to the internet to consume video from YouTube or other entertainment sites or other video hosting sites, it puts tremendous pressure on the broadband, or excuse me, on the MPLS networks that are used in the wide area network. And of course, over the last several years, there's been the rise of cloud services and software as a service applications such as Salesforce or other CRM applications, which continue to drive additional bandwidth over the enterprise wide area network. And those SaaS-based applications and cloud-based applications continue to get richer and richer every year to look like they're being executed locally from the PC. And so in addition to the proliferation of applications, the bandwidth associated with each of those applications continues to grow. And of course, this drives up the need for additional MPLS bandwidth, and MPLS bandwidth comes at quite an expense. And some enterprises have attempted to address this by building a separate internet access-based WAN that runs adjacent to their MPLS connections. The problem with this is critical apps running over the internet oftentimes suffer from the vagaries of congestion and latency that can crop up. And in addition, enterprise IT loses the ability to address those problems as well as to understand what is being consumed. Is the internet traffic legitimate business applications, or are too many employees consuming entertainment-based applications? And so the loss of visibility and the loss of manageability creates the concern for enterprise IT with this approach. And of course, that's where software-defined wide area network concept comes in, is to build a wide area network leveraging both of these technologies, internet access and MPLS services, but doing it in a way where you have visibility and control as to what's going on in the wide area network and the ability to prioritize those applications which are mission critical versus those that are not a priority for the enterprise. And so that's the concept of a software-defined WAN. And now I'm going to turn it over to Greg. He'll go through the business case for migrating to a software-defined type wide area network. Greg?
Hi, thank you very much, Carl, and thank you to Citrix for having telegeography along today. And over at telegeography, I manage our enterprise networks benchmarking service. And so what we're going to do today is run through these exact kind of scenarios that Carl has mentioned and see how that's going to lead to some cost savings by switching from that all MPLS environment to some of these available WAN alternatives. We're going to use some global examples, but in particular for those hypotheticals, we're going to focus on the EMEA region. You may or may not know this, but 2015 is in fact the year to which Marty McFly traveled from 1985 in the movie Back to the Future 2. So I've been getting as much mileage out of that as I can over this year in presentations, and it's a really good springboard for us to think today about how moving from that all MPLS network of the past to these hybrid or alternative wide area networks that are available now can really end up saving you a lot of money across your global network. So first we're going to look at switching from all MPLS to a business broadband VPN hybrid. Then switching from all MPLS to a dedicated internet access network. And by that I should say we mean an always-on, uncontended IP port that comes with SLAs and that sort of thing. And for all of these, like I said, we're looking at some global examples, but we're going to focus in on networks in the EMEA region. So broadband definitely comes at significant savings across the globe. What we're going to look at here on this first slide is a comparison of Class of Service 3 or Best Efforts VPN at the 10 megabit port level, the same port size for DIA, and then bundling that price with a 10 megabit access line within the metro area. And we're going to compare those prices to broadband subscriptions aimed at businesses of a similar speed. So we see those 10 meg ports compared to what we call here a range of 8 to 12 megabit broadband subscriptions. Of course, broadband doesn't come in kind of the standard flavors that you have for VPN and DIA. So the way that we compare these median monthly prices is to look at a range of plans at that speed stream range within each of these countries we have listed. So while I've been setting this up, you probably have been looking at the slide and noticing a few things. First, that prices for VPN and DIA do vary considerably across the globe. You have Western Europe and North America coming in cheaper than Eastern Europe, Oceania, South Asia, and South America, where things are on this chart the most expensive. You might note that I've left any examples from Africa and the Middle East off a lot of these charts until we get to the hypothetical networks, and the reason for that is just that the prices in those regions are so much higher than other regions that it really distorts the scale when we're looking at these global sites. But so you'll see these price differences in VPN. There's certainly also price differences for broadband, but they don't follow those same geographic trends. The network competitive landscape in a lot of these countries is very different than the broadband competitive landscape. So what you get, for example, are places like the U.S., where certainly the network market is very competitive and prices for VPN and DIA are perhaps a bit lower. But the broadband ISP market may not be quite as competitive in some cases as some other countries. So you have a multiple between that broadband and 10 megabit VPN. That's still very considerably large, but not as large in other places. In the U.S., the multiple going from that median 8 to 12 megabit broadband subscription to the median 10 meg best efforts VPN and access is only about 13. Again, still very large, but when you compare that to markets such as India, which has a relatively uncompetitive and expensive network market, but a very competitive local access and ISP market, you actually see a multiple between those medians of 95 here. So really considerable savings in being able to move between a VPN and a broadband situation. Now, if we increase the capacities involved, here we've gone all the same types of data, but up to a fast E or 100 meg connection rather than a 10 meg, you'll see that these trends not only stay true, but they actually intensify a little bit. So here our average multiple between broadband and VPN is about 87. Again, the U.S. kind of at the lower end is about 14, but you have some markets like Mexico, India, and Russia that the multiple is more than 100. So some really big differences in price between broadband, DIA, and VPN. And this remains true across the EMEA region. So I've included at least one Middle East site on this chart here that I've left off some of the others so that we can get a picture of that, and certainly very big difference between the broadband price in Israel and the VPN price. But you can see for a lot of these other countries within the EMEA region that these trends stay true, and we still have a pretty big average multiple between broadband and VPN. So now let's put that into the context of a hypothetical wide area network. So what I've done here is pulled together 15 sites in key metros across the EMEA region. You have a couple there in Africa, one in the Middle East in Dubai, all around Eastern Europe, Southern Europe, Western Europe. And we've picked some pretty typical port sizes across these offices. So most of these offices are at the E1 to 10 or 20 megabit level. There's a few a little bit higher than that. We have Paris and Frankfurt at the fast E or 100 meg level, London maybe with your connection to the data center or headquarters at that gig E level. Those large capacity sites bring our average in the per site megabits per second up a bit to about 90 megabits per second. You can see the typical office is kind of at that smaller end. And you can't see it in this screenshot just because we didn't have space, but we have a typical class of service mix at each of these sites. So you have about 25% of the port at voice and video, 50% at real-time data, and 25% at best efforts. So what happens if we look at making this into a hybrid MPLS broadband network? Well, what we've done in our little benchmarking tool here is just added in an adjunct site for that broadband subscription. So we had 15 sites before, now there's still 15 sites, but 30 little prices to plug in there. And we've lowered the MPLS VPN port size by at least half, and whenever possible, lowered the access that corresponded with that as well. So you see there a lot of the E1s went down to 1024K or 1 megabit per second port sizes, dropped some of the 10 megs down to 4 megs. The gig E we've dropped down to a fast E. So we have, still MPLS at every site, but less MPLS by at least about 50%. But what we've done to make sure that that capacity is still there is added in a broadband subscription of at least that amount. In some cases, we had a plan available that was even more than the original MPLS size, so we've added that in. So the net effect is that you've actually increased the average megabits per second per site here by about 25 megs. So you actually have more capacity in this network than you had before, and you still have MPLS at every site, but broadband at every site now as well. So let's take a look at how this affects the total cost of ownership. Now, I'll just give you one little caveat there, which is that when I say TCO, there are some other factors going into the TCO that we're not looking at here. It's just kind of out of our scope. But the bulk of that TCO, of course, is made up of your access loops and your network or port services. So that's what we're looking at as an annual TCO here. And you can see that between the all MPLS VPN and the VPN broadband hybrid network, we have a pretty big difference in that total cost of ownership. So we started out at about $625,000 there for the all MPLS, and those access prices have gone down about 28%, significant certainly. The port price has dropped by about 47%. But then we need to add in some new charges here, right? Because we've added in all those broadband subscriptions. All those broadband subscriptions at the original MPLS capacity size or greater come in at about $25,000. And then Carl shared with us the cost based on that original MPLS site list and capacity list of what the Citrix Cloud Bridge 1-year TCO would look like for those sites, and that comes out to about $110,000. We put all of those together, and that gets us to about $500,000. So we've gone from that all MPLS down to a network that includes broadband and Cloud Bridge, and still saved about 20%. So let's look now at dedicated Internet access. If for some reason broadband subscriptions aren't available or that's not the right option for you, certainly there's some pretty big differences in price between still the VPN and the DIA. So we're looking here again at 10 meg class of service 1, that's voice and video VPN versus 10 meg DIA. And you see that there is a pretty significant difference even between just the VPN and the DIA. The average difference here is about 43%, meaning the DIA is about 43% cheaper than the VPN. And if we up that capacity, this trend actually increases. So here, instead of 10 meg, we're looking at gig-E and comparing that across a bunch of global cities. And you can see there's a pretty significant difference. You have certain sites such as Miami where it's not quite half, but places like Prague and even New York where there's a very considerable difference in how much you will save moving from DIA to moving from VPN rather to DIA. And of course, this stays true in Europe. Again, I've left Middle East and Africa off this chart for scale purposes for the most part, although I'll leave it to you to decide whether Istanbul is in Middle East or Europe. But you can see across Europe at these different locations, you still very much get a savings by going from VPN to DIA. Here, the average savings is about 39%. So if we put this again into the context of a hypothetical wide area network, this time what we're going to do instead of adding in sites is just to switch all of those MPLS VPN sites that we introduced earlier over to a port technology of DIA. Now, in our first scenario that we're going to look at, we've kept all of the access lines the same and kept them in there. In the real-world scenario, that may or may not be the case. If you're buying your DIA from a large provider who may not have your buildings popped, and they have to go out and source local access from a local provider, then they're going to pass that cost through onto you. Otherwise, the prices that we collect, it's very typically the case that if a carrier has popped your building and their business is based on finding customers in the buildings that they have on net, then very often this will be a bundled price that includes both the access and the DIA port charge. So we're going to kind of look at the extremes of both of those scenarios when we look at this total cost of ownership. So again, we start with the same TCO of about $625,000. And if we drop that port price from the MPLS VPN to the DIA, but keep the access the same, we have a 62% decrease in port price, which makes about a 46% difference in the total cost of ownership. Now, if you were able to source your DIA entirely across the network from providers that had access into your buildings, you could get rid of that access cost, and you see the total cost of ownership going down really significantly by about 72%. So the conclusions that we can draw from this, of course, is that obviously broadband is a tiny fraction of the cost of either VPN or DIA. Even if you're going to keep some of your MPLS, increase your bandwidth with broadband subscriptions, and maintain all of that functionality that Carl mentioned and is going to speak more about, your TCO goes down by about 20%. Or in the alternative, if you're looking at the DIA environment, DIA is significantly across the board cheaper than MPLS if you can use that as an alternative to your MPLS. That certainly varies with the geography and the port size, but that trend is pervasive across the globe between VPN and DIA. All right, so now that we've got a picture of the prices, I will pass it back over to Carl.
Thanks, Greg. So many of you might be sitting there saying, well, yeah, I just don't know, this sounds too good to be true. But in fact, Gartner indicates that this is what enterprises are starting to do, or recommends that enterprises start looking at this. So to be sure, this isn't something that Greg and I have cooked up and are promoting, but many analysts in the enterprise IT community are also saying it's time to software-define your WAN and build a WAN based upon a combination of different services, be that Internet and MPLS or even mobile 4G, to connect those users to the applications and content in the most efficient way possible. And as further evidence of that, we found some market data from Forrester. In this research report, Forrester went out and surveyed over 3,600 enterprises across the world, and amongst the battery of questions, there were 3 related to what types of WAN technologies are they using in conjunction with MPLS. And I pulled those out, and so you can see the responses for the use of DSL and cable, 4G/LTE, or Metro Ethernet services. And in all 3 cases, over half of the respondents in the survey indicated that they're planning to implement those technologies in their wide area network, or have implemented and are expanding the use of those technologies. So in addition to the business case that Greg presented, in addition to the recommendations from Gartner, what you see from this Forrester report is in fact that many enterprises are starting to move in this direction. And what's enabling them to move in this direction while maintaining the end user experience and the reliability of the application delivery and the visibility to the application delivery is a solution like CloudBridge provides for software defining the WAN. And what CloudBridge can do by sitting at either end of the wide area network, it can logically bond together multiple distinct WAN connections into one virtual link. So you take an MPLS connection and you bond it together with a broadband connection such that from an application perspective, it looks like one large pipe instead of two separate individual connections. Because we're promoting the use of internet-based connections, we do support encryption of the application traffic as it goes across the internet links. And finally, the application traffic is sent across the virtualized or software-defined WAN based upon the application needs and the link performance. And this is what provides the QoS for the end users as applications, as well as responding to changes in the network performance. And so I would like to spend a little bit of time on that last point. So because this is what separates software-defined networks or software-defined wide area networks from traditional or legacy link load balancing. And what I want to talk about on this slide is how the software-defined solution from CloudBridge is different from legacy link load balancing solutions. And there's three elements of that: application needs, network policies, and network conditions that the CloudBridge software-defined WAN solution considers. Let's start with application needs. So applications have different sensitivities to latency, jitter, and packet loss. Certain applications like voice over IP need the lowest possible latency and, of course, minimal amount of packet loss to ensure a high-quality connection, while other applications such as file downloads are less sensitive to any one of those conditions. And the CloudBridge software-defined WAN solution allows enterprise IT to define an acceptable set of parameters for each application, and with that parameter information and the network conditions, which we'll talk about in just a second, it will send applications across the wide area network links that meet those parameters for that particular application. Another element that the CloudBridge platform considers is the types of links and whether they're usage sensitive or whether they're open or internet access links versus a more secure connection like MPLS services. So let's go back to metered links. Some wide area network services such as 4G LTE or satellite connections are usage sensitive, and so you may only want to use those types of links when the primary connection is no longer available to reduce the WAN spend or ensure that the WAN spend stays within the budgets that you've set forth. And you can do that with the CloudBridge software-defined WAN solution. Likewise, for security and privacy reasons, you might want to indicate that certain applications which contain sensitive data remain pinned to a particular wide area network link, which meets your security and privacy profiles that have been set forth within the enterprise. And finally, the CloudBridge solution considers network conditions. The CloudBridge solution measures for each link in real time in each direction the performance of each wide area network link, and it places application traffic on a link or links based upon the performance of that network link, as well as the latency, jitter, and packet loss parameters that I talked about just a few seconds ago. So with all that information about the solution, I would like to provide a practical example of a customer that Citrix has recently worked with. This customer had a single data center supporting multiple branch office locations where they were using MPLS services ranging from 1.5 to 3 megabits per second in 3 different QoS levels. They also built a separate internet access link that was dedicated for their customer Wi-Fi network. And those links were separate, and the enterprise applications were dedicated to the MPLS network, and the customer internet viewing was dedicated to the internet access connection. They had a data center remotely that hosted Citrix and other enterprise applications, and they were reliant upon that single MPLS connection providing connectivity back into the data center. And those applications were mission critical, and the branch office locations relied upon connectivity to provide services to their customers. And the problem with this is that they had a single point of failure for both their customers as well as for their enterprise applications. And because they had built essentially two separate networks, they were stranding WAN bandwidth. And now with the software-defined WAN solution in place, they're able to treat the MPLS connection and the Internet access connection as one single virtualized or software-defined WAN, where applications that are mission-critical or enterprise applications as well as the customer Internet traffic share all the bandwidth together. So there's no longer a single point of failure for a particular application or a particular use case. And of course, there's much more efficient usage of bandwidth. And because the solution provides QoS, the mission-critical business applications can be prioritized over the other applications that are in use within that branch office location. So now we'll wrap things up very quickly and then transition over to take questions. But a few parting thoughts about the CloudBridge software-defined WAN solution. First and foremost, it can save you significantly. The TCO analysis done by Greg indicated a 20% plus savings, but that was using continuing to use MPLS services married up with broadband services. We have some customers that are taking a much more aggressive approach and migrating away from MPLS altogether, and as a result they're able to see significantly higher savings, up to 80% in some cases. And because these enterprises now have multiple connections running from their data centers out to their branch office locations, they have a 24/7 always-on branch because they have multiple connections and assured reliable access. With the ability to run the CloudBridge platforms at cloud service providers, applications can be delivered effectively and efficiently from the cloud out to users in the branch office. And finally, one big benefit of a software-defined WAN solution and using alternative access technologies, those are available to be turned up in days as opposed to months with traditional MPLS services, which require time to be engineered and installed. And so that's a quick summary of the benefits of a software-defined WAN solution. And with that, Greg and I are done with our presentation, and we'll turn it back to Jessica, who will help us with Q&A.
Thank you very much, Carl. And before we move into the Q&A, I would like to give everyone a reminder that you can submit your questions in the Ask a Question area on your screen. Simply type your question into the text box and click Submit. All right, back to you, Greg and Carl.
All right. I'm ready to, Greg and I are both ready to take questions from the audience. We'll just delay here just a minute or two to let questions come in. First one here coming in is actually it's for Greg. I'm going to give this one over to you, but essentially the question basically is the data in your presentation was around cities inside of Europe, but the questioner is wondering about how, for those multinational enterprises that may have connections in America or in Asia, how that changes your analysis. Can you comment on that?
Yeah, absolutely. Great question. So The big picture in that case is certainly the same, which is to say that both DIA and broadband are going to be cheaper, broadband significantly so, across global locations. In some cases, that difference is of a different magnitude. So, for example, in the case of a market like India, for various reasons there, you have, like I said, the network market is really expensive and the broadband market is really cheap. We see that kind of same thing in some other places, such as Latin America and some of those countries, where you have a fairly competitive local access market and broadband kind of market, while the network market is very expensive. So the upshot is that general trend, same across the world, but there's going to be some differences country by country, region by region, in terms of how broad the difference between your network prices and your broadband or DIA are. But everywhere you go, you're going to find this to be the case in some respect.
Okay. Just looking through a couple questions that have come in. So actually, here's another one. We'll just go back to you, Greg. It's along the same vein. So in the analysis that we did, it was focused on DIA and MPLS, and they're just wondering if you've got information on satellite and or microwave connections and what their pricing is relative to some of the other services that we looked at.
Yeah, absolutely. Good question there. So at Telegeography, we don't specifically track satellite pricing or microwave pricing. Really, in the case of microwave, sometimes we'll get a bit of that in local access that we collect, but the upshot there is it does tend to be very expensive. That's for particularly, your primary resource extraction and those kinds of industries where there's very little competition in the infrastructure or in very remote sites. So you can expect that those prices are going to be very, very high compared to network and wireline kind of prices. There's no doubt about that. We don't have a lot of specific information, but anecdotally, we've certainly seen that to be the case, that's really going to increase the price across the board.
Okay, and just to add on to that, the solution, the CloudBridge SD-WAN solution, is compatible with satellite and microwave connections. We've gone to some deployments with satellite service providers, and so technically speaking, the solution will work. Obviously, the customers out there that use those will want to probably get pricing and make sure that the business case still holds. But I think based upon, Greg, your analysis and from what you guys have seen and what we see at Citrix, it'll probably still hold true.
Yeah, absolutely. And if I could add something that just real quick to that, Carl, is just to say that that given that satellite is going to be high cost compared to something like broadband or microwave, that if you're able to have the same kind of throughput with a slightly lower capacity, that's certainly going to help you save a lot of money.
Okay. One coming in, it looks like I'll take this one, but basically the questioner is asking, I've traditionally used WAN appliances to address or to improve the economics of my wide area network. How does this software-defined WAN solution work in conjunction, or is it a different approach? And certainly the software-defined WAN solution from CloudBridge works in conjunction with existing WAN optimization solutions. And so you can leave those in place, compress all the data, and accelerate the application protocols through the existing devices that you have before using a software-defined WAN solution such as CloudBridge to increase the actual amount of bandwidth in the wide area network. So they are, it's not an either or, but they're complementary approaches to addressing the amount of the cost of bandwidth as well as the amount of bandwidth that is needed across the wide area network. So
here's another one, and I don't know if we'll be addressing that in follow-up emails, Greg, but they're wondering about getting more information from telegeography. What's the best way for them to get more details or maybe engage with telegeography?
Yeah, absolutely, great. So telegeography.com, you can look there and look under the various products and services. You can look specifically under enterprise networks and pricing, or get in touch with me, and I'm happy to answer specific questions about your network. And then finally, just in London, coming up here in London in October, early October, we're having our WAN Summit conference. So look that up, wansummit.com, and feel free to come by and meet us and learn more about how we discuss all of these issues at the WAN Summit.
Okay. And likewise, you can find out, or for our customers on our prospects on the bridge here, you can find out more information about the CloudBridge solution at citrix.com/CloudBridge, and or follow up through the follow-up emails that you'll be receiving after this webinar, or by contacting me. I'm easily available, carl.brown@citrix.com. So I don't see any more questions coming in. So we'll hang on just a few more seconds to see if anything else comes in. Otherwise, we'll wrap it up, and I appreciate everyone joining us today and checking out the virtual WAN solution and getting more information from telegeography. Greg, any parting words? Yeah. Okay.
Yeah, that's just thanks to Citrix for having us along, and happy to always discuss ways that we can save money and make things work more smoothly.
All right. Thanks, Greg. And with that, we're done.